Hey guys, welcome back. This is Harsh, and today our topic is expression tree. And what is an expression tree? So, expression tree is basically a binary tree where all the internal nodes are operator, that is plus, minus, multiplication, divide, such, and all the leaf nodes are operands. So, and basically, we are going to create an expression tree from an postfix expression. So, what's the algo for that? The algo is pretty simple. We'll read the we will read the postfix expression from the left to the right, and if we get an uh, uh, operand, then we just create a node and push it onto the stack. And again, if we get the operand, we create the node and push it onto the stack. So, like we continue pushing the elements onto the stack until we encounter any operator. And once we encounter an operator, so we are going to pop out two elements from the stack and then apply that operator to that to the two popped out nodes from the stack, and it would be its left and right child. So let's go ahead and build this algo. For this, basically what we are going to do is provide an input string which has all the operators. So let's call it. I'll take an example from the book itself. Let's take this string. And what we need is we'll create a function in which we'll feed this input string, which is our, let's call it postfix expression, right? Because that is what this string contains, the postfix expression. And what we want to create is we want to create an expression tree out of this postfix expression. So I'll create that function inside my tree utility class. And I'm going to provide this postfix expression, and I want to provide the array in its array form. So I will just use toChar array function, and this function will process the postfix expression for me, and in return it will return me a binary tree. And then we can go ahead and print our tree. So let's go ahead and create this function in our tree utility class. The return type would be binary tree, as you know. Okay, we are not passing any node or something like that. We are just passing the character array. Let's call it postfix array. So yeah, that is what we are passing, and we need to return a binary tree and output. So how do we do that? So basically we can do that easily just by passing this uh, postfix expression. And I'm just wondering, like, I should do this using recursion or in iterative way. So just give me a minute. So let's do this iteratively. So I've created a variable which will store the length of my postfix array. And now what I want to do is I want to check, and uh, I want to check if it is an operator or not. So for that, probably I can create a list of operators which I'm going to provide uh, in my input postfix string. So let's fill our list. Added addition, subtraction, divide, and multiplication. Okay, so that's our list of operators, so that we know which one we are currently processing. And now I want to run a loop from the starting of the array to its end, and I will increment it by 1 on each step. Prior to that, I would be needing a stack to hold my nodes. So what do I need to do here is, as I'm iterating through the array, so if postfix, if the index which I'm reading, and if that is inside a list of operators, so that means we know it is an operator and not an operand. And else it's an operand. If it is not in our list of these addition, subtraction, so we have a list of operators. If the character which we are reading is not in this list, it means it is an operand. So yeah, uh, so let's go ahead and first do this. So we'll create a new node, and we will want to push it to stack. So let's directly just put it to stack. So this will hold our operand, sorry, and it will keep on holding the operand. Actually, I can reduce the number of lines. So this is the only thing which I'm going to do here, and else the loop will continue. And what if we get the operator? If we get the operator, we need to pop out uh, two nodes from the stack, remember, and then we need to apply the uh, then we need to assign those popped out nodes to the left and the right of the uh, operator. I'll just use where left child. So if you remember the postfix expression, when it will be popping out, it will be popping out the left child on the second pop, and the first pop it would be popping out the right child. So it would be correct. So the first child which we suppose, if I go to this example, so we have pushed A, we have pushed B, we have pushed C, then we got to star. So if we'll push back, we'll pop from the stack, we'll get C first and then B. So but I want to keep the C on the right side, hence I'm assigning it to the right child, the first pop, and the second pop to the left child. What I need to do now is node new, or new is a keyword, node op for the operator. And I just need to pass my operator in here. I can also go ahead and assign its left and right at this point only. Left would be the left child, and the right would be the right child. Correct? And okay. And now I want to push this back to the stack. So this is basically what I'm trying to achieve, and I think we should what is saying, okay, at the end what we need to do is we need to return the last element from the stack. So that would be the final expression. Okay, instead of binary I should use node. So I'm not going to create a binary, and then I would just return the node. And here what I will do is I am assigning the output of my function to the root node of my tree. Okay, so I'm creating an object and I am using this function, and it would be returning me the root node which contains all the elements. I guess this should work. Let's run it and see. We have added it to the, yeah. I think it is throwing some error. Okay, no. So Brax first time. So okay, okay. Oh, so basically my tree was created, but the node which I am using, and it's of type int. If you go and see, so all my inputs were converted into its respective ASCII value. So if I want to get back the uh, see the tree in the alphabets and operator form, so I need to create my own traversal. Let's just quickly create one local function to cater to this exact need. I will create an infix because I don't want to spend much time on this. The root is null, just return. Else what we do in infix, we go to the left node. So infix root dot left. Once we are back from the left node, we print the node, and then we go to the right child. Yeah, I'll just call this local function on my newly freshly generated tree. And what I want to do here is I want to basically convert it back in its original form. Let's see, it has returned me my tree and the expression are correct. Let's double check it from the quotient. So it should be, we were doing infix, so a plus c into b divided by d. A plus b into c. Okay, why did it did that? And divided by d. Yeah, just let me check its postfix expression once. ABC into plus D minus. This was what we started with, I guess. ABC into plus D slash. Yeah. So the function is working fine and it is returning the values as we were expecting. So that's the end of the video, guys. Let me know in case you have any questions, and my GitHub profile would be mentioned in the description of the video. You can go ahead and check all the common functions and all the common problems I am solving. There would be many. So currently I am going through the trees chapter, so I am basically solving all those questions. And thank you.